In graphing functions using transformations, the first type of transformation is reflection. Reflection, as we all know that reflection is the image. When we stand before the mirror, the reflection, we can see our reflection in the mirror. Similarly, here while graphing the function, the reflection is the image of the particular graph with respect to a line, with respect to some line. Okay, that is only called reflection. Here, with respect to this line L, the graph f is reflected as f dash. Okay, so f is the original graph and it is the reflection of that with respect to the line L. Okay, while making the reflections, here these are all the three conditions. The graph y is equal to minus f of x. If f of x is the original graph, then it is minus f of x. The negative function is the reflection of the graph about x-axis. Minus f of x, if it comes, if the negative function comes, then the reflection will be about x-axis. Y is equal to f of minus x. The difference, the two are different. Minus f of x is different from f of minus x. Not all the times it will be equal. Sometimes it will be equal. F of x, f of minus x is equal to minus f of x. Sometimes it will be equal, but not in all the cases. So, y is equal to f of minus x is the reflection of the graph of f about y-axis. F of minus x will reflect about y-axis. The graph of y is equal to f inverse of x, the inverse function. F inverse of x is the reflection of the graph in y is equal to x. Y is equal to x. You know, y is equal to x is the line that goes on the diagonal wise of the graph. So, the inverse function is the reflection of the graph of f in y is equal to x. Look at this illustration. Y is equal to x square is the graph and y is equal to minus x square minus f of x, and it is the reflection about x-axis. So, it's reflecting along the x-axis and this is y is equal to minus x square, and it is the mirror image of this graph along x-axis. So, this is the graph of y is equal to root x. Y is equal to root x and it is f of x. Okay. So, now we have to find the root for f of minus x, not f of for my f of minus x, it will be y is equal to root of minus x. So, f of minus x graph is the reflection along y-axis. So, if it is y is equal to root x and y is equal to minus root x, root minus x is the graph which reflected along y-axis. So, minus f of x will reflect along the x-axis, but here f of minus x and it reflects along the y-axis. Now, look at this function y is equal to e power x, exponential function. Log and exponential are inverse functions. Okay, so y is equal to e power x and this is the curve of y is equal to e power x. Now, we have to, from this, we have to find the curve of y is equal to log x. Okay, so the inverse function, f is a function and f inverse is the function and it is the reflection along the line y is equal to x. This is the line y is equal to x. Y is equal to x means what? If x is equal to 1, y is also equal to 1. If x is equal to minus 5, then y is also minus 5. So, the line will go along the diagonal wise of the graph sheet. Okay, so if y is equal to e power x is this function, is this curve, then its inverse logarithmic function. Okay, inverse of the exponential function is the logarithmic function. So y is equal to log x is the curve and it is the reflection along the line y is equal to x. And the next method is translation. Translation. Y is equal to, if y is equal to f of x plus c. Okay, so translation means moving. Translation means moving. So a translation of a graph is a vertical or horizontal shift of the graph that produces congruent graphs. The same graph, but it will be translated into another position. Another name of this type of translation is shifting. Okay, so the graph, the same graph will shift. Maybe it may be left or right or upward or downwards, but it will shift. So y is equal to f of x plus c. X plus c. Inside the function, we are adding some constant. Y is equal to f of x plus c and causes the shift to the left. Left. Y is equal to x minus c, subtracting some constant, and it makes the graph to shift to the right. Okay, so if y is equal to f of x plus d, okay, so adding some constant to the function and it causes the shift to the upward, and y is equal to f of x minus d, subtracting some constant, and it causes the shift to the downward. So f of x is modulus x. Modulus, you know, modulus function we have learnt already. Modulus, it's something like a magical box. The modulus function, if you give positive values, then it will remain positive. If you give negative values, it will become positive. So if I give 1, the modulus value of 1 is equal to 1. If I give minus 1, the modulus value of minus 1 is also 1. Okay, so if I give 1, it will become 1. So 1 comma 1, 2 comma 2, 3 comma 3. If I give minus 1, then also the modulus value is 1. So the points will be 1 comma 1, 2 comma 2, here minus 1 comma 1, minus 1 comma 2. If x value is minus 1, its y value is 1. If x value is minus 2, then its y value is 2 because of the function. If I give x value as minus 5, then y value is plus 5 inside the modulus function. So the line will come like this, 1 comma 1, 2 comma 2, 3 comma 3 likewise, and here in this side also x value may be negative but y value is positive because y is equal to f of x, and f of x is the modulus of x. Okay. So f of x is equal to modulus x is this graph, the purple. So f of x is equal to x minus 1. We have to find the graph. F of x is equal to x minus 1. So the second type, x minus c, it causes the shift to the right. So 1 units, it's minus 1. So 1 units on its right. So this orange color graph, that is equal to modulus x minus 1. So f of the third type, f of x is equal to x plus 1. X plus 1. So it causes 1 unit, it causes the shift 1 unit to the left of the function, left of the graph. Okay, so it's coming here. So again, f of x is equal to modulus x, and it is this function. F of x is equal to modulus x minus 1, that is f of x minus d, and it causes the graph shift 1 units downwards, and f of x plus 1, it causes the shift 1 unit upwards. So the similar graph, but it moves upwards, downwards, right side or left side. Okay. The next method is dilation. Dilation is also a transformation which causes the curve stretches or compresses, multiplying a function by a positive constant. It causes the stretches or compresses of the graph. If the positive constant is greater than 1, the graph moves away from x-axis. If the positive constant is less than 1, the graph moves towards x-axis. Okay, so f of x is equal to x square. F of x is equal to x square is the graph, is our graph. Okay, so f of x is equal to half x square. Half, the constant here is half, and it is 1 by 2 is less than 1. So if the positive constant is less than 1, the graph moves towards x-axis. So moves towards x-axis means virinjirum. Okay. So half is less than 1. If the positive constant is less than 1, the graph moves towards the x-axis. So towards x-axis means, if this is the given graph, towards x-axis means the graph dilates and go like this towards x-axis. And if the positive constant is greater than 1, it moves away from x-axis. So it moves away from x-axis means the graph contracts like this. Towards x-axis means it dilates, and towards, moves away from x-axis means it contracts and goes towards y-axis. Okay, so this is y is equal to x square. The blue colored one is the graph of y is equal to x square. F of x is equal to half x square, and it is the dilated graph, the orange colored one, x square by 2. F of x is equal to 2x square. Here the constant which was multiplied is 2, and 2 is greater than 1. So it goes, that graph, the graph of f of x is equal to 2x square, moves away from x-axis. So it contracts. This is the graph of y is equal to 2x square. So according to this, we can draw the given graph. According to all the above conditions, we can draw the given graph without having our values. For the curve y is equal to x cube, given in figure, draw y is equal to minus x cube, y is equal to minus x cube plus 1, and y is equal to x cube plus 1. Third one, y is equal to x cube minus 1. And fourth one, y is equal to x plus 1 the whole cube with the same scale. So the graph of y is equal to x cube is given here, this line. This curve is the graph. Okay, so this is y is equal to x cube. First we have to find y is equal to minus x cube. Minus x cube means it is the reflection. It is the reflection. Okay, so the reflection along x-axis, y is equal to minus f of x is the reflection along x-axis. So along x-axis it has to reflect. So you have to reflect like this. Or திருப்பி போடுற மாதிரி. Okay, so this curve will go upward and this will come downward. So the graph of y is equal to minus x cube will go like this. திருப்பியாச்சு, இப்படி இருக்கிறது அப்படியே இப்படி திருப்பியாச்சு along x-axis because it is minus f of x. தெரியுதா minus? Okay. Now y is equal to x cube plus 1. So x cube, this is x cube graph, y is equal to x cube. X cube plus 1, x cube plus 1, that is f of x plus 1. So it has to move 1 unit upward, 1 unit upward, f of x plus 1. So it causes the graph to shift upward for 1 unit. So the same graph and this will be. Okay, so it has to move 1 unit upward. y is equal to x cube minus 1, that is f of x minus some constant. So 1 unit, it causes the shift downwards. It causes the shift downwards for 1 unit. So the graph should move down for 1 unit. Shift downwards for 1 unit. Okay. Now y is equal to x plus 1 the whole cube. It is x cube. It is x plus 1 the whole cube. So here it is y is equal to f of x plus c. Constant is adding inside the function. F is equal, y is equal to f of x plus c. So it causes the shift towards to the left, towards the left of the given graph. So the graph will go like this. Okay, 1 units, it is shifting 1 units to the left because it is x plus 1 the whole cube. Similarly, the second one, for the curve y is equal to x power 1 by 3, that is cube root of x. Given in figure, draw y is equal to minus x power 1 by 3, y is equal to cube root of x plus 1, y is equal to cube root of x minus 1, and y is equal to x plus 1 cube root of x plus 1. Okay, so it is similar to the previous problem and you can do it by yourself. Now, sixth question. From the curve y is equal to x, draw y is equal to minus x, y is equal to 2x, y is equal to x plus 1, y is equal to half x plus 1, fifth one 2x plus y plus 3 is equal to 0. So, from the curve y is equal to x, y is equal to x, that means the value of x and y is equal. So, while writing the points, if x is 0, then y is also 0. If x is 1, it is 1. If x is minus 1, y is also minus 1. Okay, so that line, the graph goes diagonally. And we have drawn the graph for y is equal to x. Now, we have to draw y is equal to minus x, that is minus f of x. So, the graph reflect along the x-axis. If this is the line, if this is the curve, then for y is equal to minus x, it is minus f of x. So, the graph reflects along the x-axis. So, if it reflects along x-axis, then it goes diagonally like this. Can you understand? It is reflecting along x-axis. Okay. So, the line will go like this for y is equal to minus x. This is the line for y is equal to minus x. Next, the first one. Okay. So, second one, y is equal to 2x. Now, we are multiplying a constant 2 with the function y is equal to 2x. So, we are multiplying a constant 2 with the function. The 2 is greater than 1. So, if the value is, if the constant value is greater than 1, then the function, the graph y is equal to x dilates or moves away from x-axis. So, it moves, now it is like this. So, y is equal to 2x. So, the graph moves away, not towards, away from x-axis. That means it will go like this. So, this is the line for y is equal to 2x. Can you understand? It goes away from x-axis. So, y is equal to 2x. Third one, y is equal to x plus 1. Y is equal to x plus 1. this is the line for y is equal to x, and this is our original graph. Now y is equal to x plus 1. With the function we are adding one constant. So it causes the shift above, sorry, not upwards, it causes the shift upwards for 1 unit. So for 1 unit the same line moves upward. So it will come like this, 1 unit. For 1 unit it moves upward. So the same line and this is y is equal to x plus 1. It moves upward from the original graph. Okay. Fourth one, y is equal to half x plus 1. So y is equal to half x plus 1. First we have to find the graph for y is equal to half x. Then we can add 1. Then we can shift the graph. Okay. So first half x. Here it is half. Half is less than 1. The constant which is multiplied here is less than 1. So the original graph, this is the original graph, and it moves towards the x-axis, right? It moves towards the x-axis. So the graph of y is equal to half x. This is y is equal to half x. Now we have to find y is the graph for y is equal to half x plus 1. Half x plus 1. The function plus some constant. So it causes the shift upward for 1 unit, right? Now this is the graph, this is our graph, and it causes the shift for 1 unit upwards as we are adding a constant. Okay, so this line will be parallel to this y is equal to half x, but 1 unit upward. So this is a line. Y is equal to half x plus 1. Okay. Now the last one, fifth. Y is equal to 2x plus y plus 3 is equal to 0. Sorry, not y is equal to 2x plus y plus 3 is equal to 0. So from this, y is equal to minus 2x minus 3. Y is equal to minus 2x minus 3. So first you have to draw the graph for minus 2x. Y is equal to 2x we have drawn already. So y is equal to minus 2x means the function, that is minus f of x. So the graph should move, the graph should reflect along the x-axis. Am I right? So this is the line of y is equal to 2x. So this line will reflect along the x-axis. As it is minus 2x, it will reflect along the x-axis and the graph will come like this. This is only f is y is equal to minus 2x. Can you understand? So this is y is equal to minus 2x. Okay, y is equal to minus 2x. Now we have drawn for y is equal to minus 2x and minus 3. Y is equal to minus 2x minus 3. That means it causes the shift to the downward. Minus 3, or constant 3 to subtract பண்ணிருக்கோம். So it causes the shift downwards for 3 units. So 1, 2, 3 here. 2. So from this 3 units it should come down. So the graph will come here and this is our y is equal to minus 2x minus 3. Now I have explained this, but girls, you have to write the reason for each and everything. First you have to write y is equal to minus x. Y is equal to minus x, as it is negative, as the function is negative, it should move, it should reflect along the x-axis. The reason should be there under the graph. You can draw all the lines in one graph, but you have to write the steps or the reasons below the diagram. Okay. So the explanation is like this, as follows. First, draw the graph for y is equal to x. First one, y is equal to minus x. The graph of y is equal to minus x is the reflection of y is equal to x about the x-axis. Yes, it is the reflection. Second, y is equal to 2x. So as 2 is greater than 1, the graph moves away from x-axis. Y is equal to x plus 1. So the graph causes the shift upward for 1 unit. Y is equal to half x plus 1, 2 steps are there. So first you have to draw the graph for y is equal to half x. As half is less than 1, the graph of y is equal to x moves towards x-axis for y is equal to half x. Now for y is equal to half x plus 1, the graph of y is equal to half x shifts upward, for 1 unit. And the last one, so fifth one, 2x plus y plus 3 is equal to 0. That implies y is equal to minus 2x minus 3. First, we have to draw the graph for y is equal to minus 2x. The graph of y is equal to 2x, already we drew this, reflects along the x-axis. Y is equal to minus 2x minus 3. The graph of y is equal to minus 2x shifts downwards, as it is minus 3. Minus 3 shifts downwards for 3 units. The reason should be there. Write the steps to obtain the graph of the function y is equal to 3 into x minus 1 the whole square plus 5 from y is equal to x square. So write the steps. So we are going to write the steps alone. In the first step, you have to draw the graph for y is equal to x square. Because from y is equal to x square only, we have to draw the graph for this function. Okay, so y is equal to x square. In the second step, the graph of y is equal to x minus 1 the whole square. We are taking this alone. Okay, so y is equal to x minus 1 the whole square. That is the graph that shift right for 1 unit. Okay, it is x minus 1. So the graph is shifted for 1 unit on the right, towards right. Now we are taking this 3 alone. So 3 into x minus 1 the whole square. So this graph y is equal to x minus 1 the whole square moves away from x-axis, because we are multiplying it with a constant 3 and 3 is greater than 1. So the graph of y is equal to 3 into x minus 1 the whole square moves away from x-axis. And the fourth step, with this y is equal to 3 into x minus 1 the whole square, with this graph we are adding some constant plus 5. So causes the shift for 5 units in the upward direction. So plus 5 ன்றதுனால 5 units upward direction க்கு போகும். These are the steps to obtain the graph for y is equal to 3 into x minus 1 the whole square plus 5 from y is equal to x square. Seventh one, from the curve y is equal to modulus x, draw y is equal to x minus 1 plus 1, y is equal to x plus 1 minus 1. It is modulus, right? Y is equal to mod x minus 1 plus 1. Second one, y is equal to mod x plus 1 minus 1. Third, y is equal to x plus 2 minus mod x plus 2 minus 3. So you can draw the graph for y is equal to mod x. These are all the shiftings only. Okay, so how to draw the graph for y is equal to mod x? So this one is the graph of y is equal to mod x, the blue colored one, because the points if you give for x and mod x, right, y is equal to mod x. So, if I give 1 for x, y is also 1. If I give 0, y is also 0. If I give minus 1 for x, what is y? Y is plus 1. If I give 2 for x, then y is also 2. If I give minus 2 for 0 was for x, then y is also 2, not minus 2, because the modulus absorbs the negative. Modulus la iri function irukumbodhu negative value kuduthonala adu positive aidum. So the graph will come like this. After drawing the graph, you can do all the shiftings. The third one, graph the functions f of x is equal to x square and g of x is equal to cube root of x on the same coordinate plane. Find f composite g and the graph it on the plane as well. Explain your results. So, as it is given, graph the functions f of x and g of x. We are given some random points and find the points for y. Okay. So, f of x is equal to x cube. These are all the points I have get, and for cube root of x, g of x, these are all the points we have get, and we have to find f composite g. So, f composite g of x is equal to f of g of x, that is f of g of x is cube root of x. So, cube root of f of cube root of x, then cube root of x the whole cube, as f of x is equal to x cube, that is cube root of x the whole cube. So, the cube root and the cube will get cancelled and it is equal to x. That means f composite g is a identity function. That means f and g are inverses to each other. That we have learnt, that we can prove as a theory part. Now, we are going to prove the same using the graph. So, we have plotted the given points in a graph. So, 0, 0, 1, 1 and minus 1, minus 1, and then 2, 8 and minus 2, 8 for f of x is equal to x cube. Similarly, for cube root of x also we have plotted the points in a graph and I have drawn the arcs. So, this is the graph of y is equal to x cube and it comes like this. Similarly, this is the graph of y is equal to cube root of x. I have drawn both the arcs. Now, look at the graph. These two arcs, one arc is going like this and another arc is going like this, and these two graphs are the reflection of each other, and the two graphs are symmetric to each other, symmetric with respect to this line y is equal to x. This is the line y is equal to x, and these two arcs are symmetric along with this line y is equal to x. That means this arc is the mirror image, this arc is the mirror image of this arc, and it is symmetric to the line y is equal to x. That means the two functions are inverses of each other. So, here we know that f of x is equal to x cube is the inverse function of cube root of x. Here f of x is the reflection of g of x about y is equal to x, because about the line y is equal to x, these curves are getting reflected. So, this is the conclusion we need to write. The fifth question, from the curve y is equal to sine x, graph the function. First, y is equal to sine minus x, second one y is equal to minus sine minus x, third one y is equal to sine pi by 2 plus x, and fourth one y is equal to sine pi by 2 minus x. So, here x, and we have to find the values for sine x. When x is equal to 0, sine 0 is equal to 0. x is equal to 90, its sine value is 1. Here instead of 90, we are writing pi by 2. As pi is equal to 180 degree, pi is 180 degree, pi by 2 is 90 degree. So, here now mostly we are writing it in radian measures only. Okay. So, pi by 2 is 1 minus pi by 2 is minus 1, and pi, that is 180. I can write this as 2 pi by 2 also, 2 pi by 2 also, 2 we can cancel. So, it is pi. So, 2 get cancelled and it is pi. Pi is equal to 0. It is minus pi or minus 2 pi by 2. Okay. So, here in the sine, its maximum value is 1 and minimum value is minus 1. So, it will go on like this. So, as it varies between 0, 1 and minus 1, the sine curve will go like a wave. We call it a sine wave, and we learn about this in our third unit. Now, it is just an introduction. So, it goes like a wave and it varies between 1 and maximum value is 1, minimum value is minus 1. So, it will go on like this. Okay. So, now this is the curve for sine x, y is equal to sine x. So, now the usual shifting and reflection only we are going to do. Y is equal to sine of minus x. So, f of minus x. F of minus x is equal to, f of minus x is the reflection along y axis. F of minus x is the reflection of the graph along y axis. So, I am going to reflect. I am going to flip and திருப்பி வைக்கிறது. Okay. So, this curve for y is equal to minus sine x, I am going to flip. I am going to turn the curve upside down. That is, I am going to rotate. I am going to turn it towards the y axis. So, this is the curve for y is equal to minus x. So, first write y is equal to sine of minus x. So, y is equal to f of minus x is the reflection along the y axis. So, the curve we will turn the curve, but you will get the same curve here, but it is also a curve, but while rotating, while turning it along y axis, it will go like this. Okay. So, it will go like this while turning it along the y axis. So, next one, y is equal to minus sine minus x. Minus, this is the green one is y is equal to sine of minus x. Okay. Now, the next one, the third one is y is equal to minus sine minus x. Now, we have found y is equal to sine minus x. The next one, minus sine minus x, that is minus f of x. So, we are going to reflect it along the x axis. We are going to reflect this green colored curve along the x axis. So, if I reflect, if I rotate it along the x axis, we will get the original y is equal to sine x curve. So, minus of y is equal to minus of sine minus x curve while flipping it, while reflect it along along the x axis, you will get sine x. Okay. So, the third one, y is equal to sine pi by 2 plus x. X plus some constant, y is equal to x plus some constant inside the function. So, it causes the shift, the first curve, x plus pi by 2. So, it causes the shift along the left for pi by 2 unit. So, the same red colored curve moves left for pi by 2 units, moves left for pi by 2 units. So, it will come like this, moves towards left. Okay. And the last one, fourth one, it is sine pi by 2 minus x. Sine pi by 2 minus x is equal to sine minus x plus pi by 2. We can write like this, minus x plus pi by 2. So, minus x plus pi by 2, adding some constant to minus x, which is, this is our y is equal to sine minus x curve, and I am adding some constant pi by 2 with this. So, if I add some constant to this curve, the green colored curve should move along the left for pi by 2 units. This green colored curve should move along the left because it is only our minus x, sine minus x curve. So, while adding pi by 2 with this, it should move along the left for pi by 2 units. Okay. So, what do you get? The green colored curve, if it moves for pi by 2 units, it will go like this. Okay. So, this is our curve. Okay. So, while drawing this, you can draw this thing as a separate drawings also in your note. It will be easy for you to understand. And write the reasons behind, write the reasons under the graph, reasons for every parts under the graph. So, eighth one, from the curve y is equal to sine x, draw y is equal to sine mod x. From the curve y is equal to sine x, we have to draw y is equal to sine mod x, and this is our eighth question. So, it is a modulus function, sine modulus function, right. So, for modulus function, if you give negative values, it will be positive, right. In the case of sine, y is equal to sine x if x is greater than or equal to 0. If x is greater than or equal to 0, it is sine x. If x is less than 0, it is minus sine x. Okay, sine oda minus. X க்கு lesser values கொடுத்தோம் அப்படின்னு சொன்னா, it is minus sine x. Okay, this is our sine curve, and in the previous problem itself we have studied it. It varies from +1 to -1, and it's going like a wave, sine wave. Okay, 0, pi by 2, 2 pi by 2, 3 pi by 2, it keeps on going. You see, it is a sine wave. So, for the positive side, if x is greater than or equal to 0, it is sine x. Okay, it is sine x. For x is less than 0, it is minus sine x. So, for the positive side, this curve is okay. But for the negative side, this is not the original curve. We have to find sine of modulus x. So, for the positive side, the curve will go like this. Okay. So, this is our original sine curve, and for the positive side, I have drawn the same curve. We have to draw for y is equal to sine mod x. So, for the negative part, it is sine minus x, right. So, it should be this same curve should be reflect along the y axis. The same curve should get reflected along the y axis. So, இது அப்படியே reflect ஆகும்போது it will go like this. Okay. So, I think you can understand the difference between these two curves, and this is our original sine curve, but this is our y is equal to sine mod x, and this curve is the reflection of this curve along the y axis. Now look at this ma. I have extended the graph. I have extended the part. So this is our original sine curve, and it is here. This line is our original sine curve. That is, this curve is our y is equal to sine x, our usual curve. And by this curve, the next curve, okay, this is our original curve y is equal to sine x, and the another curve is the reflection of y axis. Which curve? This curve is the reflection of y axis, and it is only sine of y is equal to sine of mod x. Okay, now you can understand. I have extended the curves, and this is the reflection. Sine of mod x is the reflection of the sine curve along the y axis. So the graph of y is equal to sine of minus x is equal to minus sine x is the reflection of the graph of sine x along the y axis.